Hi everyone, and welcome to challenge 10 of my 65 days of TypeScript challenges. Like, we're already at challenge 10, and it feels like I started this yesterday. Today's challenge, I'll be looking at includes. Before I jump into looking at includes, I just want to remind myself that I have been making mistakes, two key mistakes. One, not looking at the documentation. Two, not reading the TypeScript errors, the errors that I get from the type checker, right? In two occasions, when I was working on the Concat challenge and I think it was the awaited challenge. If I had just taken some time to actually understand the TypeScript errors, I would have been able to do those much quickly. So yeah, that out of the way, let's jump into includes. Hopefully we'll be able to do this in about 20 to 30 minutes. So includes. So yeah, what do we want to do? Implement the JavaScript array.includes function in the type system. It takes two arguments. So here we have a tuple, an array type structure, and dio, and I'm guessing we want to check, yeah, we just return a boolean that says whether or not dio is included in the first argument. So that's very straightforward. Let's jump into the challenge. Awesome. Cool. Oh, this is the most test cases I have seen for any TypeScript challenge. Um, but yeah, first thing I'm going to do is just look at the test cases and then look at the stubbed out code we're going to implement, and then we get cracking with implementing. First thing is the test cases. So we're taking an array of strings, we're checking if a string exists in the array. Same thing for the second test case. These test cases are more or less the same, more or less the same. And this is interesting. We are taking, ooh, this is interesting. Is this looks like it's poorly formatted. So what we have, oh, okay. So what we have is passing. What we have is, first of all, an array type structure with one element, an empty object, and then an object. Oh. But it's not wrapped in anything. Is that even possible? Because that becomes two objects. Oh, of course, of course. What we have is an object with a parameter a value string a, and we're checking if this entire object is included in. No, it's not. Okay, cool. Okay. The pretty much test cases are pretty much what you'd expect for this type of problem. You have cases where you have different types entirely. Okay. Now, next thing is, before jumping into, well, coding this, let's see, what's my approach gonna be? If we find the argument on the right hand side in any of the arguments on the left hand side, then we return true, else we return false. I mean, yeah, the idea that comes to mind is we kind of just map through all the arguments on the left hand side, and then in a conditional, we check if the argument on the right hand side is any of those elements by using the extends key, well, let's call it keyword operator. And yeah, so okay, let's do this. K in a small t in t. So first of all, Mapped object type implicitly has an any template type. I'm not quite sure what that means. But the idea is if t extends u, then we want to return true, else false. Yeah, so straight away I can see issues with this. First of all, this is saying this is not assignable. Okay, t in key of t, and then we get back our value by going into t. So let's create a test. I can already imagine a situation where we have an object of Boolean values, and I guess we can do a next step in that and see if we find true in any of these in any of those values and return true. If we find false, if we don't find true, then yeah. Okay, so type tests gets the value includes let's just use the first test case here, cars and cars. And what do we get back? Yeah, so we get a tuple that contains Boolean values, and what I'm going to do is kind of reduce those. The logic we want to do here is if there is a single true, then return true. We can achieve that by creating I was going to say a union intersection. We can find the intersection, the intersection of true and false. Ooh, that's interesting. I'm not quite sure what, like in Boolean logic, the intersection of true and false is false. But I'm not quite sure what that comes out to. In terms of the intersection of sets, true and false, I think that will be never. Type C. True and false, never. Okay. But anyway, when we're done, we're going to end up with if we intersect everything, we're going to end up with one of three cases: true, false, or never. If it's not never, just return. Oh no, that doesn't help us. I think I'm almost there. I just need to figure this out. And I will just start from the beginning. If there is a true in this tuple, we want to return true. And if there's no true, we want to return. So we can create a union. I wonder what the union of, we can create a union of all those things, and then just check if true extends that union. So I just want to confirm what the union of true and false is. Boolean. That's too broad. I want it to either be, okay, how about true and union of false and false? False. I think we can work with Boolean. Union of true and true. It's true. Maybe we can work with this. We can work with this. I think we can work with Boolean. The idea being, if after we create a union of everything in the tuple, if true extends, if true extends, but then false will extend. True will not, okay, cool. So true won't extend false. And the union of false and false is false, hopefully. I mean, I don't see what else it could be. False, cool. So if it's all false, we'll get false, and true will not be able to extend false. But if if there's any true, it'll become Boolean and true will be able to extend that. So cool. The next step here is therefore to, can I take the output of this, I wonder if I can do type convert, I just say to tuple, to Boolean, to, yeah, let's just say it's Boolean tuple, and that will take the exact same thing, same inputs. So that will do this. I will do this, and then we will use to Boolean tuple. Okay, let's just type. We will pass in, yes, these values. I don't think we need this just yet. I don't think we need that at all. For the basis at all. Expected. Oh, I don't need to do that anymore. Okay, cool. Now, if this extends, what did we say? We said if it extends Boolean, then we're going to return true. Else we're going to return false. Well, close. I mean, we got some test cases, but not all of them. Okay. What are we doing wrong? Let's see. Okay, cool. We have that. What are we getting? We're getting false. We're getting false, even though type test 2. What do we get for? What do we get for to Boolean? Let's copy this. Paste that there. We get true, false, false, false. Okay, so to Boolean tuple is working as expected, but this logic is wrong. The reason, yeah, so what we've forgotten to do is to Boolean tuple, I don't know if this will work. Number, no. Let's see. What happens? We didn't turn it into a tuple. What happens when we do that? Now it's a tuple. Sorry, no, yeah, now it's Boolean. It's hard to explain this without actually being able to show it, but doing this turns it into a union of all those. Okay, let me do it this way. Test union, type union, not test. Union T to Boolean, and okay, just make this clear. So what we get from to Boolean tuple is a tuple of Boolean values, true or false, and then what we do when we basically iterate through every value is the union of every single value in to Boolean tuples outputs, which then becomes a Boolean. And I'm curious to see what happens if I change this to something that is not inside there. Do I get false? I get false. And if it's, yeah, something that's not inside there, I get false. So if there is a true, if this extends Boolean, let me do it the other way. If this extends false, return false, else return true. Close, but we're still not getting all the cases correctly. Now, what's the issue? We okay. Let's start with this one. Start with this one. Let's first, yeah, let's just copy in the full input, and then let's replace those. Let's also replace those. Yeah, finally let's replace these. Okay, so first of all, apparently it is true that there is boolean in this what do you call it, tuple, but that's not true. If t of t true extends u, let me do the if I switch it around, say u extends t of t, does that fails even more test cases? They consider that in the test cases. So yeah, I would need to understand exactly how to do I do more thorough how to make sure I'm factoring in cases where the value in the tuple is actually a subset of the value we're checking for, but not the exact set. Now, how do I do that? Is there any way to say extends exactly? Or to check the equality of types. Okay, there is a type of operator. I don't know. I don't know that there's an equality operator. What's the error? It just says expected. But there is a type of operator. Does that help us though? I don't know if that helps us get the type of the value. The type of is boolean. The type of boolean is boolean, right? Type C1. Type of false. What's that? Is this not how to use the type of operator? Or does he have? If that's a string, does that work? Okay, cool. It doesn't. Identifier expected. Okay, let's look at the documentation for type of. Funny enough, I think this is one of those operators that exist in both the value and the type space, so it can be very confusing. There's a type operator. Yeah, so this is the value. Let's end of type of type context refer to the type of a variable or property. So you can use the you can use the type space type of operator in the value space to refer. Oh gosh, that's like okay. Let's see. So if this were a value, then this would work, is what that's saying. But it's not. So we can't use the type of operator. Back to the problem. How do we check whether true? Okay. We're checking whether Boolean extends true. We're checking whether But here we'll be checking whether false extends boolean. If we're simply using the extends operator, we'll be inverting the problem. As const. Nope. Okay. Okay, I'm stuck. Gonna try and find on online, even though I think this was covered in the effective TypeScript handbook. Check equality of types in the type space. Looks like a very specific question. A type guard. Oh, yeah, you can do something in. There's an in operator. The in operator. And I notice here that the in operator is a value space operator. And so, given I was coming up on time, I just decided I'll stop where I stopped. I didn't pass all the test cases. The ones I didn't pass were cases where the two objects kind of had the okay. So the cases that are failing are cases where the values, the types in the tuples actually do extend the the types that we're checking against. I don't know off the top of my head how to make it such that, for instance, here 1 extends the union of 1 and 2, read only A extends that, and A extends read only. Yeah, and I don't know how to explicitly check for exact equality. So far, I have relied on the extends operator to check subsets against the other. Maybe 1 more minute before I actually look at the solutions. If we're looking at sets, TT extends U. Okay, so let's just walk through it. If true extends boolean, but is true boolean, we should have a sub utility that checks if something is another thing. And actually we do. This equal. So equal xy takes, I don't know what that is. So it takes, oh yeah, and I remember looking at this way back when I started, how they achieved this. So if t extends x, return 1, 2 extends, no, this is, I'm just going to use equal. I'm not going to re-implement it. If equal t u, there we go. I love how with TypeScript I don't have to import from the top. For some reason, it works even when I import things further down. Um, I mean, since I'm using equal, I may as well just explain again how it works by going to the definition, refresh my knowledge anyway on how it works by picking the definition. Remember the first time I did my challenge, I was curious about how is any, not any. I don't think I actually looked at how equal works, but maybe I did and I couldn't understand it at the time. So it takes two types, and then what's this? It checks if a generic type that takes t extends x, returns 1, else returns 2, extends a generic type that takes t extends y. Yeah, just gonna understand how it's like we're executing this generic type yeah, I couldn't understand this. So in the next session I'll have a look at this. But yeah, I'm stopping here for today.